Hello, good afternoon. My name is Ashraf Badawi. The team is part of Zuwaid City of Science and Technology in Egypt. Our presentation today is titled Balancing the Role of Machine Learning and Teacher in the Adaptive Learning Guidance Systems that we are trying to build at Zuwaid City. Thanks for giving us the opportunity to present our work to this great audience. We wish to have been with you in person, but hopefully we'll get the chance sometime in the future. So one of the questions that was asked prominently is, how do we balance the role of the teacher versus the machine learning? They apparently are not speaking the same language. The multiple dimensions and multiple parameters that can be readily assessed and put into context and put into use by a machine learning algorithm would make the teacher not able to follow up what the recommendations and why are these recommendations being made. And we would like to suggest that how can this balance be achieved. So we start by the problem statement. What are the two main components of the ALGS? Why is the teacher role crucial in adaptive learning systems? Why is the collaborative nature of the environment important? And where do we see the best contribution of the machine learning? And now go back to the role of the teacher. How do we maintain an active role, a central role for the teacher and mentor in the adaptive learning process? So the problem statement is the adaptive learning environment can have different flavors. Some are intelligent tutoring systems, some are learning analytics. Some assume that it's a one-on-one, some assume that there is a classroom environment, and relying solely on deep learning came with concerns about how do we include motivation, procrastination, engagement, and other items that might not be present, might not be readily available for machine learning to assess. What is the motivation for me to do this? Where do I see myself heading? A lot of stuff, a lot of dimensions that the teacher can add to the process that might be not easy for a machine learning algorithm to include at all. Artificial intelligence can perform tasks beyond human capabilities, obviously, which may result in a level of complexity in the system that would generate adaptation that the teacher might not be able to interpret readily, and might actually be counterintuitive for in instances where the teacher knows something about this or that student that might not agree on this is the best step to overcome this hurdle for the student. The novelty of the ALGS is proposing how does this balance could be, and this is definitely under development, how this balance can be achieved. How do we balance the strengths that's brought on by the machine learning and the human factors in an attempt to reduce this gap or apparent gap between mixing the role of the machine learning and the teacher? So the two main parts is that the ALGS is based on the teacher and the computer-supported collaborative environment, and the human guidance and computer-supported collaborative learning are both suggested to work side by side. So the system hopefully will merge the strengths of both domains in a sense of collaborative filtering or adaptive guidance system, not a totally adaptive system. So the adaptive guidance system has the teacher, which is has a specific content model. So the teacher has an experience with this content, has a good understanding of how this content can serve the learning objectives for and the learning plan and the learning path for each one of these individuals, what decisions need to be made, and how the recommendations can be reviewed periodically in order to modify the path in order to achieve or overcome hurdles. On the other side, CSCL can have different elements, which is facilitating group work, making individual tasks, having discussion forums, a whole bunch of elements and affordances that can be quite useful for the students to advance down the learning path. How do we merge the strengths of both into this adaptive learning guidance system, the machine learning that would measure what the environment can tell us about the students versus what the teacher know, and how can the teacher's experience benefit this process? So why is the teacher role crucial in the adaptive learning system? Adaptive learning system deploys the mentor's physical existence with technology to maintain a healthy learning environment that corresponds to the individual's learning needs. So basically, this could be in a classroom environment, in a one-to-one settings, offline, online, depending on what's the teacher file, what's the learning the profile for the learner that the teacher maintains can tell us about that learner. What motivates him or her? What sort of procrastination? Is she engaged, not engaged? Is she keeping a cohesive learning environment online? What can be enhanced in this interaction? How can this interaction work to the benefit of the learner? That's obviously something that cannot be obtained without a human overseeing this process. Just to assume that the environment and the sort of one-to-one interaction with the material that a learner can have within the session can simply give us what since I can measure that, since I can measure this particular action, or I can measure this particular response, then I know the mental process that is accompanying it. There is a lot that can go that would change that picture in terms of, is the student engaged or not engaged in an online session? Is it did the student open the assignment as soon as he got it? Did he start? When did actually they went online and accessed the material and looked at the videos? Were they skipping through the video? Were they motivated? All of this stuff that can be measured but can only put into context with what we know about the student through the teacher, him or herself. So why is the environment itself? The environment gives affordances to facilitate group interactions, whether in the same place, same time, different place, different time. All the different modes of interaction can only be supported by good environment, enabling the learner to exchange ideas and help each other to understand the topic and answer the questions in a collaborative way. This is the environment can have affordances that would make this interaction a lot more rich and can have enable both synchronous and asynchronous modes, and can have positive effects that goes way beyond a classroom environment, which is definitely this setting, which is same time, same place, can definitely be part of the modes that can be facilitated by the CSCL. So if we have the role of the teacher on one side versus the role of the machine learning on the other side, teacher can be creating the database upon which the system filtering function is based. So we have a whole bunch of content, we have a whole bunch of attributes that the collaborative filtering can work based upon, feeding the system with the data about the learners and the results of the face-to-face interaction in the classroom and outside it, suggesting an initial path. If there is no data, then there is no data for the machine learning to work upon, and having this individual model. So even if we have a model for the content, we don't have a model for the learner, and how these two will interact with each other. So the initial path is definitely the job of the teacher. So we can have a pre-assessment and then an initial path that's set by the teacher, receiving a system alarm that's tracking the history of a particular student if they are exhibiting behavior that is totally outside. So even if we're talking about many students taking the course at the same time, if some of them are, their behavior and their interaction with their peers and with their with the material is totally outside, and this can bring up an alarm to the teacher, reviewing and refining the system-generated recommendations, keeping on top of the learning process, and intervening and taking proper action either in the class or feeding the adaptive decision to the system. So all of this can be the role of the teacher. On the other hand, the role of the machine learning is building a reliable user model. So this user model with its multiple attributes is the key in the adaptation process, collecting data about the student's action, behavior, all what we can measure about them, of course within all the constraints about what we can and cannot measure, what we cannot give consent towards recording, detecting any deviation from the behavior of the learner from the peer group. So this is something that if somebody is doing something that is way outside their peer group, then this is an alert for the teacher to come and see if there is something happening here. If somebody that is skipping too much into this video, is there something about the video or about the learner? What is it that needs to attract the teacher attention to what's happening with that particular situation? Generating automated recommendations, obviously, but then this is an input to the teacher. So it's only if the teacher gives the option that this would go directly to the student, that this will go unchecked directly to the learner, or if there is high confidence from the system that what we are measuring about the student is not very much different from their peer group and not different from the expectations on the learning path, then this typical cases can just simply progress with their own individual pace through the recommendation path. And processing highly time-consuming analysis, of course, as per what we expect from the machine learning, tailoring the adaptive recommendations based on the user model which has input from the teacher. So basically what we envision this working is we create the content models, what the student should be learning. So we have learning objectives, we have skills, we have this entire matrix that we normally build for the learning path, and then what the student should be learning and what content could fill out this interaction matrix. And then we build the user metrics by psychometrics, by collaborative filtering, by peer assessment, whatever we can build about the user beforehand. So we have a user model that is initial. So we have initial content model and initial user model that we can have pre-assessment and psychometrics that we can measure about the student. And then we start adding recommendations. So, okay, so for that particular student in this particular situation, given what we know about them, then this is the path that we recommend. And then we can now make learning decisions. What we can measure about the students during the session, after the session, while interacting with the material, online, offline, what time did they start, how much time did they take, what sort of difficulties. This would have this adaptive component, in the sense of, okay, so this information for the teacher can either choose to pass this information as it is, or can modify it based on what they know. Once we add elements that can measure the engagement of the students during the session, then this is actually more ears and eyes to the teacher to sort of know whether there is a learning difficulty here, or simply the students were not paying attention during the session. This is our references, and once more, we are grateful for this opportunity. This work is still under development. We are glad to take any questions from the audience. Thanks, and have a good afternoon.
All right, thanks so much, and thanks for being here in person as well as with the pre-recorded talk. So enjoy that. And we have the chat if people have questions, and as the questions may come in. So I want to start with one question. It's very, I haven't seen anything else that really tries to integrate AI and the teacher side, kind of the way that you're doing here. Do you see the role of the teacher in your system evolving over time as technology changes? Is that something you might envision down the line?
Definitely, the role of the teacher will evolve with the more actions, more information about the learner we can measure. First, if you're talking about a regular classroom, a small group, regular classroom, and then MOOCs, the role of the teacher in any one of these, depending on what information I can get about these learners. And before we say machine learning, one of the points that I was trying to make in my presentation is that we do not have the data. So the machine learning assumes that we have a long history of interaction of these students with these data, or typical students with typical data, so that we can have an interaction history, so that we can give useful recommendations. If we don't have this, if we just have starting with content, how can we start building this? So this is where the teacher actually can be quite useful, because the teacher is going to be the memory for the system. The teacher is going to be the source of experience. Okay, in my history, in my experience, that this is the typical path. If somebody did this and then this and then this with these alternatives, then that could be the typical path. Add to this an initial user model that can lead to enhanced recommendations. So the teacher, if he has a smaller number of students, can devote individual attention to tuning each user model. If he's talking to like 1,000 students together, then he's going to rely on peer groups, that these learners sort of look like each other in the context of taking that particular course or this particular material. So if they are sort of behaving in a similar way, the system is not going to raise an alarm. So the system will keep generating alarms that this guy is typically not engaged, this guy is typically skipping through the videos, this guy is typically not reaching out for the material except like 5 minutes before the next session is here. Then more attention can be devoted from the teacher to these outliers in terms of their behavior and interaction.
So are you looking at the teacher being used to both to basically to seed the system with specific information about an individual learner as well, an individual student, to help build that user model?
Yes.
Okay.
So in absence of data to jumpstart the recommendation system, then the teacher is the possible source for such initial recommendations.
Okay. Is there a sort of an online interview process of sorts that the teacher would follow to fill out everything that you're looking for to seed the system with information for a particular student?
So basically what I do, and I'm guessing that this is common for typical professors and teachers, that they have an initial plan. So basically, I taught that course before. I have this learning objective. These guys typically come to me when they have these gaps in their understanding. So here is what I'm gonna try and how do I address these gaps. If I apply an initial assessment to this, I give them a quiz in the first meeting to sort of know, okay, to verify my assumptions about them. That's how I would handle it. I'm guessing that this is the way that it can happen. So the way that if I'm going to sign up to take this course, this is the plan, the initial plan that I am signing up to. And this is definitely close to 100% depending on the teacher experience in the first few runs.
Okay, all right. Now that makes sense. Is there a part of this then, either now or over time, that would look at a particular user, a particular student across courses, like not just specific to one course, but would you be able to leverage information taken from several courses for one student and start to get a feel for sort of who they are, what they like, what they're likely to skip, and all that kind of thing?
Okay, what I'm going to say is notwithstanding any limitations on what can and we cannot measure and privacy concerns and so
Sure.
if we put this
Yeah.
to the side for a minute, the user has a typical behavior.
Mhm.
If this guy is typically engaged, attending the online sessions, attempting the problems, and that for that particular course, he's not engaged, he's not accessing the material, he's not. So there is something here that we can know about. Is this typical for this guy, or this is not his typical way of interaction? Then this is something that if this guy never raises their hand, if this guy never participates in group exercises, this guy is that's typical for him, then okay, then we know that he's not comfortable with group interactions for one reason or the other. So the user model definitely have aspects that can be generalized to other courses. So we have a profile for the learner that we can update across courses for sure. And this is something that if we have the guy entering the program at the first year, first semester, all the way through the end, of course, it begs the question what happens after that. But at least for that life of the program, we should have a very reliable user model after a few courses.
Yeah, no, that's great, and that's really interesting. One more question. You mentioned, I mean, you talked a little bit about classrooms and you talked about MOOCs. And so, what do you see the role? Do you see the role of the teacher being in terms of data collection then being different because you can get some more information from from the machine side for MOOC than you could for a classroom? So how is the teacher role different in sort of seeding the information database in classroom versus MOOCs?
So if it's a classroom setup, then the teacher has a lot of options in terms of probing questions, in terms of online surveys, in terms of group exercises. But when it comes to MOOCs, if the user consents to sort of turn on their camera while interacting, then we can measure out about their engagement. Mm-hmm. If not, then at least with the pattern of interaction with the material itself can give us some further clues. It's the role of the teacher for the classroom. Obviously, his bandwidth is divided to a lower number of students, which can give like individual attention to. If I only have 30 students, I know each one of them by name. I can ask probing questions and know that I have the time and effort and energy to go back to their history and see, okay, so why is he not engaged in my class, and to sort of review his user model as a whole. In MOOCs, of course, that becomes a lot less possible. Hence, it's what I am able to measure in MOOCs. Since we are a university, we have the assumption that this is a classroom is typical because our groups are groups of 30 at the end. We have not really considered a whole bunch of metrics specifically for MOOCs, but we are building models using the camera that would measure quite successfully engagement with gaze detection and mouse clicks.
Mm-hmm.
You can tell a lot about if the person is engaged or not engaged, even if their gaze is fixed towards the screen. Their mouse clicks can still tell us whether they are engaged or just have their eyes fixed on the screen.
And if they know the camera's on, they may do that, I suppose, right? They may they know if that's, they know what the test is and how to game the test if it comes to it.
Yes.
And that's something to work around. Okay, no, go ahead.
Please go ahead.
Yeah. One last question. I'm curious. Is it what stage are you at this point? Is it in terms of being able to roll this out and use this with actual teachers and students, or how far along are you in terms of being able to start to gather information and have people try it out in real use cases?
We are working on top of Moodle. We have some of our research going towards building this learners engagement. I think some of them are in our references. We are trying it for like 5 courses. We started with one in the fall semester, and then we had it in 5 courses. But the people teaching these 5 are also the researchers and PIs and co-PIs for the project. So there is a lot of still hands-on, and it's like sort of collaborative filtering. So we're still measuring. We're not getting very high confidence in the recommendations from the system yet.
But it's early on. But still, you have real people. I mean, they are researchers, but they're real use cases already, right?
Yes, these are real courses. These are real courses that are currently running in our. And of course, we picked math courses since they are the easiest to measure and see progress, and because most of it is ends with numerical metrics.
Okay. Well, terrific. Well, this is really fascinating, interesting work. I hope to keep up with it. We're kind of just at the end of our time, but I appreciate you coming on and joining us virtually from Egypt. And it's great to have you here. Hopefully, we'll see you back next year. And I really love to see how the progress continues. It's great to talk with you.
Thank you so much for this opportunity. Thank you. Thanks, everyone.
All right. Thanks again.